talking about different patterns that we're going to use when we use multiplication. So what I'm going to show you first, and this I'm going to throw back and forth. I'm going to bring it up multiple times, that way we can use it. Let me get it switched over here. I'm going to throw this up there, and we're going to use this multiple times throughout the lesson, and we're going to refer back to it, because whenever we talk about multiplication, there's proper grammar that we have to use. So whenever I get to the point of the lesson where I'm asking you guys questions and you guys are helping me work through problems, these are the vocabulary words that I'm wanting you guys to use, okay? So whenever we're talking about the answer to a multiplication problem, that's what we call the product. So whenever I ask you, so what is the product of your answer, or the product of the question that I'm asking you, I'm talking about what is the answer? What answer did you guys come up with? Okay? And if I ask you guys, what are the factors? What are the factors of that equation? I'm referring, let me find my mouse here. I'm referring to these numbers. The numbers that you're multiplying together are your factors. So in this equation right here, 3 times 4, those are your factors, 12 is your product, okay? Or whenever I ask you guys, there's going to be some questions where I ask you guys to work them out for me and tell me how you got your answer or how you did that problem. When I have you guys work that out for me, I want you guys to use these terms for me, okay? And then your multiples are the products you get when you multiply numbers by 1, 2, 3. We're going to be more talking about our products and our factors though. So if I ask you guys the value of a number, I'm asking you how much that number is worth. Okay? So if I ask you, today we're going to be talking a bunch about tens, hundreds, thousands, multiplying by those numbers, multiplying by exponents. And so when I ask you the value of a number, I'm asking you how much it's worth. So in that case, I'm going to be asking you, is the value of 100, is that greater or less than the value of another number? So is the value of 100 greater or less than the value of 10? That's an example for you guys, okay? And so you guys have gone through your properties a bunch, okay? So our commutative and our associative properties, those are the ones that we use, the power of commutative properties of multiplication, right? Okay, so our order of operations, that's another one we're going to be using today. I know we have talked about it at least the past 2 weeks that I've been here on Thursdays. So we all know PEMDAS, okay? PEMDAS is the order that we're going to use to solve our math problems. So first we have to go and we have to do our parentheses. I don't think that there's a bunch of parentheses that we're going to be using today, but we are going to be using exponents, okay? And we're going to be using multiplication. So whenever I tell you you're going to have to know PEMDAS for this lesson today, I'm expecting to at least know exponents and multiplication. And then whenever I ask you guys questions, and this isn't lined up how I had it, but it's okay, I'll explain it. So when I ask you guys a question, I ask you, what are the non-zero digits of this problem that we're getting ready to use? Do you guys think, what do you think I'm talking about when I ask you the non-zero digits, Corbin?
Like the digits without any zeros?
Yeah, the digits that aren't zeros. It's pretty self-explanatory, right? So when I'm talking about the non-zeros, and on my paper they're pointing, this arrow is pointing to the 7, and this arrow is pointing to the 6, okay? And this is going to make a little bit more sense once we start working out our problems. But when I ask you guys what the non-zero digits are, and I'm going to bring that up a lot today, I'm referring to any digits in our multiplication problems that aren't zeros. And most of the time, I think, well, all of the time today, those are going to be at the beginning of our number, okay? So when I asked you guys today, and I'm going to pull this back up quite a few times, but we're going to be using this product and factor. We're going to be using those vocabulary terms a bunch today. And if you guys use incorrect grammar, I'm not going to smack you on the hand. I'm just going to ask you, how do we put that in multiplication? How do we put that in mathematical terms, okay? So we're going to bring this up a bunch today. So what we're going to do go ahead and get out. You're gonna need a pencil, and you are going to need, let me see. Is this right? Let's see. You're gonna need a purple and a red colored pencil. Okay, you wanna go ahead and grab those out for me? A purple and a red. Everybody got out a purple and a red? Give me a thumbs up when you're ready, when you got out your two colors. I'll give you about 5 more seconds and then we're gonna start. Everybody good? You have a question, Bryce, or you giving me a thumb? Giving me a thumb? Okay, nope, you're good. I just wanna make sure you know the question. So today we're gonna be using, you guys can go put your hands down. Today we're gonna be using a bunch of zeros. Okay, we want to make sure we're correctly counting the amount of zeros that are in our problems. Because if I pay you guys, if I had you guys come to my house and wash my dishes for me, and I told you I was going to pay you $300 to wash my dishes, and then I only paid you $30, would you be pretty upset with me? That I only paid you $30 instead of $300? What's the only difference between those two numbers?
A zero.
1 0. There's 1 0 at the end that makes the difference between me paying you $300 and me paying you $30. And whenever you become an adult, those zeros start to matter. And I'm going to be pretty upset if you start messing with my paycheck and taking off my zeros. Okay? So especially when any math problem, it's important to have our zeros. But in the real world, when we're talking about money, if you guys become bosses someday, or if you become what they call bookkeepers. Bookkeepers are the people that deal with your paychecks. They add up your hours that you work, and then they pay you for what you worked. If any of you become a bookkeeper one day, and you take off somebody's zero at the end, you're going to be hearing from them. I promise. Okay, so what we're going to do is I'm going to go through, and I'm going to work out the first couple of them with you. I'm going to walk them through with you step by step, and I'm going to explain to you exactly how we're going to work out these problems, and then I'm going to start having you guys help me walk through them. You guys are going to tell me how to work through them, okay? So we're going to start with number 1. Okay? So for number 1, if you guys look down here at the bottom, we're going to be finding the products. Okay, remember how I said we're going to be coming back to that term a bunch. Our product is our answer. If you look down here, we have 3 different products, or 3 different problems that we're going to be working out together. We're going to do them one at a time, okay? So for number 1, we're going to start out with 10 times 6. And I know you guys all can probably do that in your head, okay? That's mental math, but we're going to work out all of these problems the same. Even though you may be able to blurt this out to me right here off the top of your head, we're going to do it like we're going to do the rest of our problems. That way, if you guys want to come back to this and look at it later to help you, you guys have all the notes that you need, okay? So what we're going to do is we're going to take our red colored pencil, pull out your red colored pencil, and we're going to underline all of our non-zero digits. So if we're talking about our non-zero digits, we're talking about any number that's not a 0. So in this equation, we have a 1 that's not a 0, and we have a 6 that's not a 0. Okay, then we're going to pull out our purple colored pencils, and we're going to underline all of the zeros in our problem. In this problem, we only have 1 0. Okay? Now, one other thing thing that I'm going to pull up and I'm going to throw over here to show you guys. Hang on, we're going to get there. I'm going to pull up. Have you guys used these blocks before? Maybe in 4th grade? They're called base 10 blocks, right?
Mm-hmm.
So I'm going to come up here and I'm going to show you. This is going to help each and every one of you, especially on these problems where we have a bunch of zeros. If I touch this, will it move them down?
Right now, no, it won't. You're going to have to go over to the button on the side where it says home.
You know what? It's okay. I will show you. I'll explain it up here, and then I'll go back over and I'll drag them over with my mouse. So this is a base 10, okay? This is worth how much? Everybody? 10. How much is this worth?
100.
How much do you think this is?
1,000.
1,000, okay? How many of these are going to fit in here?
10.
10. So for every 10 of these that we have, it becomes one of these. This is 100, okay? And then how many of these are going to fit in here?
120. No, 1,000.
How many 10s?
100.
100. You're going to be able to get 100 10s into 1,000, okay? How many of these are going to fit in here? 10. You're going to be able to get 10 hundreds into 1,000, okay? This is supposed to be a virtual, it's almost kind of like a game, but it's more to help you guys be able to visually look at this and see how we break down numbers by tens, hundreds, and thousands. So if you guys are struggling maybe with your homework and you want to pull up, it's called oryxlearning.com. If you guys want to pull this up, you can pull these numbers over here virtually, and I'll go back over here and I'll show you. You guys can pull up these numbers virtually, and it will show you exactly, let me get back over here. Where's my mouse? It will show you exactly your quantity. I'll tell you that every time. It'll show you exactly the quantity that you have pulled over. So if I pull this over, now I have 110. Okay? So if you want to use this to help you visually be able to see the difference in tens, how many tens go into 100, you can count. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One of these rows is also going to have 10 in it, okay? And then if you count across, there's 10 rows across, and eventually if you want to count all the way up to 100 to check and make sure there's 100 blocks in there, you can, but I'm not going to. Okay, so we're going to pull this up and we're going to look at it, and if you guys want to use that for your homework, if you guys ever are struggling with your homework and you want to visually be able to see those blocks because you can't necessarily, you guys are having a little bit up there. You guys are having a little bit of trouble thinking about your hundreds. How many tens can go into 1,000? Okay, that's what that virtual model is for, and I wanted to bring that up to you guys because I think that's something that you guys can use if you're struggling with the value of tens and hundreds and thousands. Okay, so when we go back to this problem, we have underlined our non-zero digits in red, and we've underlined our zeros in purple. Okay, so what we're going to do is we're going to start by multiplying our non-zero digits together. Okay, that's what we're going to start with. What's 6 times 1?
6.
It's 6. And then when you multiply anything by 10 or 100 or 1,000, and you have those zeros at the end, what do you need to do? You just need to add them to the end, right? You need to add however many zeros you have in your problem to the end. Okay? So we have 1 0. So when we multiply our factors together, our product is 60. Okay? So we're going to move on down to 100 times 6. Go ahead and write this down on your papers. 100 times 6 out your red colored pencil. My non-zero digits are still 1 and 6. We're going to underline those in red. Is everybody underlining?
Mm-hmm.
Okay, I'm going to underline this in red. Now we're going to pull out our purple colored pencils. And so far, we've done everything in this problem that we just did in the one before, right? Except this time, we don't have only 1 0, we have 2 zeros. We are going to underline both of those zeros in purple. Six times 1 is 6. And I don't just have 1 0 that I need to add. The number 100, the number that we're multiplying by, that has 2 zeros.
So we add 2 zeros.
So we're going to add, correct, Ailey, I hear you back there. We're going to add 2 zeros to the end of our number. Okay. Now we are going to move on to 1,000 times 6. We're going to underline it with our red colored pencil, our 1 and our 6 again. And then the number 1,000, it's one of our factors. It has 3 zeros. We're going to underline all 3 of those zeros. Okay, we're going to do our non-zero digits first. 6 times 1 is 6. And the number 1,000 has 3 zeros. So we need to make sure we're getting all 3 of those zeros added in on the end. And then our product is 6,000. Okay, number 3. Moving on down to number 3. For number 3, we are going to start with 20 times 3. So, we started number 1 multiplying by tens, hundreds, and thousands. In number 3, we don't have a 10, a 100, or a 1,000. But we have a 20, right? We have a 20 and we're going to get up to a 200 and a 2,000. Can we still work this problem out the same way?
Yes.
We can, right? Because 20 is a multiple of 10. So what we can do is we can work this out the exact same way. We're going to pull out our red colored pencils. Our non-zero digits is what we're going to be underlining. So anything that's not a 0, we're going to underline our 2 and our 3. In this problem, this first one, we only have 1 0. We're going to underline it in purple. we have to multiply our non-zero digits together first. So which ones are our non-zero digit numbers? The ones that are underlined in red or purple? You guys can just tell all together, red or purple?
2 and 3.
Red. 2 and 3, the ones we've underlined in red. So we're going to multiply 2 times 3 first. 2 times 3 is 6. Come back over here. We can't forget our 0. How many zeros did we underline in purple?
1.
We underline 1 0. We're going to add it on to the end. 20 times 3, what's our product?
60.
60. Okay. $200 times 3. Same thing, pull out your red colored pencils. Our non-zero digits are 2 and 3. We're going to underline those in red. And the number 200 in it has 2 zeros. Underline those in purple. What's our non-zero digit numbers?
2 and 3.
2 and 3. Those are underlined in red, right? We're going to do that first. 2 times 3.
6.
And how many zeros do I need to put at the end?
2.
Can't forget about our zeros. Can't leave them hanging. I'd much rather you pay me $600 than $6. I'm not going to work very hard for $6, okay? But if you told me you're going to pay me $600, I think I'd work pretty hard for that, okay? So don't forget your zeros at the end. Okay? 2,000. And take out our red colored pencils, same thing. Underline our 2, underline our 3. Take out your purple colored pencils. How many zeros are in 2,000?
3.
3. Two times 3?
6.
How many zeros do I need to add?
3.
What's my product?
6,000.
6,000. Alrighty. Moving on down to number 5.
0. The non-zero digits, so that will be 3 and 4 with your red.
Perfect.
And then you want to take your purple and underline the zeros. They're only 1 0.
Perfect. And what are the numbers called? What are these two numbers called? Do you remember?
1 0.
They are, the 3 and the 4 are non-zero digits. Hold on, let me get my mouse. Get my mouse. But what if I have 30 times 4? I'm multiplying those numbers together. What term am I going to use? What are those numbers called? Factors. You're right. Good job, Abby. So our factors. Our factors of this problem are 30 times 4. We are going to break it down even further, and we're going to multiply together our non-zero digits first. What's my non-zero digits, Addie?
3 and 4.
3 times 4. What is 3 times 4?
12.
12. Is my answer 12?
No.
No, I still have to add in that 0 at the end, right?
Yes.
What's this number called?
A product.
My product, right? Everything else. Remember? My product is the answer to a multiplication problem. Okay? The product. $300 times 4. Who wants to walk me through this one? Lucas, you want to walk me through it?
So you underline your non-zero numbers in red.
The non-zero digits in red, which are number or non-zero digits?
3 and 4.
3 and 4. Now what do I need to do?
Get your purple and you underline the zeros.
You underline our zeros. How many zeros do we have?
2.
2. Now what do I need to do, Lucas?
Just solve it.
You're going to solve it, right?
Yeah.
That was a good term you used there. We're going to solve it. How do I solve it? What do I need to do?
You do 3 times 4, which is 12, and then you add those 2 zeros, so it's 1200.
And it's 1200.
Or 1200.
1200, right? Those are the same term. He said 1200 first. Have you guys ever heard it? Have you guys ever heard 1200 just be called 1200? Those are essentially the same number, okay? So 1200, 1200, that's our product. 3000 times 4. Somebody else, walk me through this one. Avery.
So, you grab your red, and you underline the non-zero digits, which are 3 and 4. And then you grab your purple, and you underline the zeros,
There are 3 zeros in 3000, right? Right? Okay, so for all of you up here who maybe can't hear Avery back there, she said you need to take your red colored pencil, underline your non-zero digits, which are your 3 and your 4. Then she said you need to take your purple colored pencil and you need to underline all of your zeros. And the number 3000, there are 3 zeros. What do I need to do next, Avery? For those of you up here that can't hear Avery, she explained that beautifully. She said I need to multiply 3 times 4. 3 times 4 is 12. She said then you need to look back at your number 3000 and you have 3 zeros there underlined in purple. You need to add those 3 zeros onto the end of your 12. Okay, because your answer is not just 12. If we're multiplying by 1000, you know your answer is not just going to be 12. We need to add on our 3 zeros, and what's our product, Avery? 12,000. Bennett, do you have number 5 done? Okay. Everybody feeling confident in that? Okay. Last one in this section, and then we're going to be moving on to something else. Number 7. Number 7 is 50 times 7. We're getting into some bigger numbers now, right? We're not multiplying by 1s and 2s anymore. We're getting into bigger multiplication facts. Who wants to walk me through what I need to do to multiply 50 times 7? Somebody want to walk me through it? Somebody new? Corbin, what non-zero digits do I need to underline?
The 5 and the 7.
The 5 and the 7. I'm underlining those in red. That's what we've been doing this whole time, so we're going to stick with it. We're going to underline those in red. I'm going to underline my 1 little 0. I'm going to underline it in purple, because we don't want to forget about it at the end, right? We got to make sure we come back to it. Bryce, what numbers do I need to multiply together?
The 5 and it's in the 7.
The 5 and the 7, because those are our non-zeros. What is 5 times 7? Anybody?
35.
35. Good. Am I done?
No.
What do I need to look back at? The 50. The 50 still has a 0 at the end, right? We need to make sure we move it over to our product. What's my answer, everybody?
350.
350 is my product. Okay. 500 times 7. I'm going to underline my 5 and my 7 in red. My 0's in purple.
Yep.
I'm going to multiply my non-zero digits together first to make my life a lot easier, right? 5 times 7?
35.
How many zeros?
2.
These 2 zeros over here in 500, we're going to plug those in here at the end. 3,500. That's my product. One more. Everybody ready for me to go on?
Yep.
5,000 times 7. Pull out your red colored pencils. I'm going to do the same thing I've been doing. My 5 and my 7 are my non-zero digits. The number 5,000 consists of 3 zeros. Five times 7.
35.
How many zeros are in the number 5,000?
3.
3. We have 3 zeros in our problem. 35,000. Okay, that's 1 through 7. Okay. Number 9 is 70 times 6. The way we have this laid out is a little bit differently than what we've been doing up top, but we're doing the same thing, right? Okay, we're going to take our red colored pencils. Which numbers are we going to underline?
The 7 and
The 7 and the 6. Then it was like super duper quiet, but he said it. The 7 and the 6. I'm going to underline my 0 in purple. We're going to come back to that, okay? We're gonna hold off on our 0. What's 7 times 6?
42.
42. What number do I still have to put at the very end?
The 0.
The 0 that's in my 70. I can't forget about it, okay? It's my product.
420.
420. Number 11. $4,000 times 8. What's my non-zero digit numbers that I'm going to underline in red? 4 and 8. I've got 3 zeros I'm going to underline in purple. Eight times 4.
24.
32.
32. How many zeros do I need to add?
3.
The answer is 32,000. It's my product, right? 32,000. Flip over your paper. If you guys still have room, you can keep working, but I'm going to flip over my paper. Number 13. 8 times 60. In this problem, my bigger number is on the bottom. Is that going to matter how I work this problem out?
No.
Okay, what's my non-zero digit numbers? 8 and 6. And how many zeros do I have?
1.
1. We're going to underline our non-zero digits in red and our 0 in purple. Eight times 6.
48.
48. I don't know who said that, but thank you. How many zeros do I have at the end?
1.
1. What's my product?
480.
480. Number 15. 15 is 40 times 400. Can somebody walk me through how to do this? Lucas, you want to give it a shot? What do I need to do first?
So you get your red
Okay.
and you underline 4 and your other 4.
Okay.
And then you underline your zeros in purple.
Mm-hmm. Now what do I need to do?
You do 4 times 4, which is 16.
I'm going to take 4 times 4. Why am I multiplying 4 times 4? Why am I not doing 40 times 4? Corbin, why am I multiplying 4
wait.
times 4?
Because those are your non-digit numbers.
Those are my non-zero digits, right? So go ahead, Lucas. Keep telling me. I'm doing 4 times 4, which was what?
16.
16.
And then you put in your 3 zeros because 40 has 1 zero and 400 has 2 zeros.
Perfect. Did everybody hear Lucas? You don't just have 2 zeros here in 400. You also have a 0 up here in 40. You have to add in all of your zeros. Okay? So we have 3 zeros. What's my answer? What's my product?
16,000.
16,000. Number 17. 4 times 2,000. this one? Riker, you want to try? You want to walk me through it?
Yeah.
Okay, walk me through it.
Get your red color pencil out. Underline 4 and the 2.
Okay.
And then get your purple. And then circle the zeros.
Underline our zeros, right?
And then 4 times 2 is 8.
4 times 2, that's our non-zero digits. So 4 times 2 is 8.
And then put your zeros.
2,000 consists of 3 zeros. We can't forget those. Okay, we're going to add in our 3 zeros at the end. What's my product?
8,000.
8,000. Number 19. Six times 60,000. You want to do it for me, Corbin? Go ahead.
So you underline your non-zero digits which is your 6s with your red color pencil. Then you underline your zeros and your 60,000 with your purple color pencil. And 6 times 6 is 36.
6 times 6, that's our non-zero digits. We're going to multiply those first. It's 36. Go ahead.
Then you add your zeros in it. You add your zeros.
How many zeros do I add?
4.
4 because there's 4 zeros in the number 60,000, right?
You get 360,000.
Okay, 360,000. 21. You guys see what we're getting into now? 7 times 10 to the power of 2. Throwing in an exponent. My order of operations. Am I going to be multiplying this equation first, or am I going to do my exponent first? I'm going to do my exponent first, right? Because when we think of PEMDAS, our parentheses comes first, but we don't have any parentheses in this equation. We do have an exponent, right? So, what we're going to do for this one, we are going to work out, we're going to underline this in red, or 10 to the power of 2, because we're going to do it first. Okay, we're going to pick it out. What's 10 to the power of 2? How do I, Corbin, talk me through how to work out 10 to the power of 2. Do you remember our exponents?
No.
That's okay, we'll get it. So, when we multiply anything to the power of 2, to the power of anything, means it's that number, so 10, multiplied by itself that many times. Okay? Is that a little refresher on our exponents? So 10 to the power of 2 means we're going to multiply 10 times 10. So we're going to do that first. Oh, I'm in my red. What's 10 times 10? Abely? 100. Okay, so we've worked out our 10 to the power of 2. What's still left in our equation? 7. Now, we're going to do what we've been doing this whole time. Our non-zero digits, we're going to underline in red. Our zeros, we're going to underline in purple. 7 times 1. Everybody? 7. What do I still need to add?
The 2 zeros.
The 2 zeros. What's my product?
700.
700. Twenty-three. 23 is 4 times 10 to the power of 4 times 10. What do I need to do first? If I'm looking at PEMDAS, okay, if I pull PEMDAS back up down here, what do I need to do first? Leah and Avery are both over there whispering exponent. Okay, we need to do our exponent first. Okay, so underline 10 to the power of 4. We're going to do it first. Harrison, what do I need to do to work out 10 to the power of 4? Do we know? Does anybody want to try? Go ahead and try for me, Harrison. Okay, so an exponent means we're going to multiply that number by itself that many times. Okay? So I have 10 to the power of 4. I'm going to multiply 10 times itself how many times?
4.
4. Okay. So 10 times 10 times 10 times 10. That's essentially, they write it 10 to the power of 4 because if you start getting into 10 times 10 times 10 times 10 times 10, that's a lot of multiplication, okay? That's a lot to look at. It's a lot for your brain to have to process. So when you get used to working with these exponents, they're actually very nice. They're kind of scary looking, but they're very nice to have because you don't have to write out 10 times 10 times 10 times 10. You can do 10 to the power of 4. What's our answer, Avery? What was it? Say it with confidence. You got it. You got it right. Just say it. 1,000. Now, over here in my original problem, I've only worked out this exponent. I still have another 10 that I can multiply this by. What do I need to do when I multiply by this 10? If we're still working with our 10s here, we're going to do 1,000 times 10. We're going to bring it over. What's 1,000 times 10? So, let's keep working this out the way we've been working it out. What's 1 times 1?
1.
Underline in red. Underline our zeros in purple. 1 times 1 is 1. And how many zeros do I have?
4.
4. Am I done?
No.
No, we still have a 4 hanging out, okay? We can't forget about our 4. 10,000 times 4. Okay, we're breaking this problem down as far as you can break this problem down, okay guys? So if you have a homework problem and you get something that looks like this, you have it, as long as you've been writing what I've been writing, you have it written out completely, okay? What's 10,000 times 4? What do I need to do? What do I need to underline in red, Kinley? What do I need to underline in red on this one? The 1 and the 4. And how many zeros do I need to underline? 4. 1 times 4? 4, and then I need to do what? Add all my zeros on the end. How many do I have? 4. Kinley, what's my product? 40,000. Okay. So, what we're going to do next, we are going to move. We still have word problems that we're going to work out. And we still have word problems that we need to work out. But what we're going to do is we're going to move on to a game. You guys all like games?
Yeah, I do.
So what we're going to do is we're going to be playing the same game that you guys use for review. We're going to move into groups. Okay, we're going to go to this pod and that pod back there where Avery and Joe are sitting. We're all going to sit facing the board. Okay, so we've played this 2 times at least since I've been here, so I know you guys know how to play. Okay, I'm going to break you up into groups. You're going to move over. Team 1 is going to be up here in Harrison's pod. Team 2 is going to be back there in Joe's pod, okay? Let me see here. James isn't here. So if you guys, while I am breaking you guys up into groups, go grab you a whiteboard and a marker. If you want a whiteboard and a marker, grab you some scratch paper. Okay? Riker, do you care to hand me the buzzers back there? Thank you. He's not here. Thank you, Riker. The two you guys have been using?
Yeah.
Okay, that'll work. Team 2, Lucas. Team 1, Harrison. Team 2, Leah. Team 1, Bryker. Team 2, Bennett. Team 1, Addie. Team 2, Corbin. Ooh, I have an odd number of you guys here today. So, Team 1, Avely, and Bryce and Joden are both going to be on Team 2, okay? So go ahead. Ready? You guys got 10 seconds, go. Team 1, Team 2. So I know for your guys' review games, you guys are some of the captains, okay? We're not going to do captains. What we're going to do is whoever gets the answer first is going to buzz in. I still have to call your name for you to get the point, okay? The only thing about this game is I need everybody to answer at least once. That's the exception. Okay? Everybody has to answer at least one problem. So if you think you're confident and you know the answer to this, but you're scared, answer the one you think you're gonna get right. Okay? Because I need everybody to answer at least once. Okay? So Corbin, can you see the board?
Yes.
You can? Okay. So Harrison, you're my doorbell. And then Kinley, or not Kinley, Leah, will you come with this for me? Okay, you guys are the car horn. Okay. Alrighty. Everybody ready?
Yeah.
Harrison,
16,000.
16,000. 30,000? What you got?
30,000.
30,000, let's see. We do a 3 times 1 is 3. I have 1, 2, 3, 4, 5. It's not 30,000. What number is that? So it's close. You were super close. Can you read that number for me?
300,000.
300,000. So, in Lucas's case, chances are we forgot a 0. So if you guys need to slow down and underline all of your zeros, do that, okay? So he did his 3 times 1, but then he only added 4 zeros. I don't know if he didn't add all 5 zeros. How did you do that, Lucas? Did you just forget a 0 in there? Or did you just forget to read it? Did you just not read it off right?
I think I forgot to read it.
You just didn't read it off right. That's okay. That's what this is for. This is to help you guys, okay? I would rather you guys take this slow and get it right than try to be the first ones done, okay? Okay, this one's a little harder. Harrison,
4,000.
let's check your work. How did you work this out, Harrison? What did you do first?
So I times 10 by 10 times 10.
And that is
100.
100. And then what did you do? Walk me through it. You're okay. You did 10 times 10 and you got 100. Then what did you do? If you're looking at this problem and we start underlining in red and purple,
Yeah, on the 1, 4, then with purple the zeros.
purple means zeros. What do I need to do?
1 times 4. 1
No, you're fine. 1 times 4 is 4.
Yeah.
And then I needed to,
Add your 3 zeros, which is 4,000.
you said 4,000, right? Okay. Bennett,
140.
what'd you say?
640.
640? I think he's right. So Bennett did 8 times 8, which is
64.
64. And then what did he add to the end?
0.
Is 0. Okay. I'll write it over here first. Addie,
100,000. No. 100,000. 120,000.
120,000. How'd you get 120,000?
So first I times 3 times 4, that got me to 12. And then I added the zeros.
All 4 zeros, right?
Yes.
Okay. Okay. For this next one, I need somebody new. Somebody that's not Harrison, Bennett, or Addie, or Lucas, because Lucas answered one also. Okay, somebody new. That's 40 times 700. I don't know if you guys can read that or not.
Okay.
40 times 700. Corbin,
28,000.
28,000. So you did 4 times 7, which is 28. He added his 3 zeros. 28,000. Somebody who hasn't gone yet. I heard this group first. Who buzzed in? Kinley? What's your plan up? 2,000. Let's see if she's right. So, when we do our exponents first, we do 10 times 10, which is 100. 2 times 1 is 2. Add our zeros. Say 2,000, Kinley? Is that what you said? Okay, so I still need Riker, Abilene, Bryce, Joden, and Leah. Okay, we don't have too much time left. Okay. Joden.
400.
400. So Joden did 4 times 1. He added his zeros. 400. Somebody new. Leah.
80,000.
80,000. So Leah did 4 times 2, which is 8. And she has 1, 2, 3, 4 zeros. So who do I still have left? Ailey, Breaker, and Bryce. Okay. Now, if you guys over there want to work it out and help Bryce, or if you guys over here want to work it out and help Ailey and Joden, Breaker, sorry, wrong one, kid. So you guys can help each other out, okay? Help each other work it out. Okay, don't just tell them the answers. You can help them work it out though. Bryce, did you buzz in?
No.
Who buzzed in? Lucas, you can help him, Lucas. You guys got 10 seconds to work it out. Help him work it out.
2,000.
2,000. So, when we do our exponents, 10 to the power of 3 is 10 times itself 3 times. So 10 times 10 times 10. 1 times 1 times 1 is 1. We have 3 zeros. Times 2. 1 times 2 is 2. We have 3 zeros. Okay? Now, Averly and Bryker, I want you guys to work this one out together. Okay? If you get it right, you get a point. And then we're going to move on. Okay? You two work this one out together. Okay? what do we do? What did you do first, Avalie?
We times 4 times 2,
Okay.
which is 8, and then we added 4 zeros, which was 80,000.
Which is 80,000. Okay. At the end of the game, you guys tied. It was 5-5. Okay? Now, I know this isn't like your guys' normal review games that you do with Miss Shook, but this was to help you guys. This is a new lesson. You guys don't usually do review until it's time for tests. So this was just review for your lesson, okay? Do you guys feel good about multiplying with the patterns, okay?
Yes.
Do you guys feel confident in your vocabulary words? If I asked you what factors were, if I asked you what the products were, do you guys think you'd be able to explain those to me?
Yes.
If I asked you what your order of operations were, can you explain that to me?
Yes.
Okay. Do you guys feel confident in your exponents now that we've done a refresher?
Yes.
That seemed to be a little stick in the mud. Okay. Our exponents. We know that 10, or say we have 10 to the power of 3. That power, that number, that's our power, our exponent, means we are going to multiply that number by itself however many times our exponent is. Okay? So 10 to the power of 3 is 10 times 10 times 10. Okay? That's how we do our exponents in that problem, and then we work out the rest. So, what we're going to do now, I'm going to give you guys your homework. What you're going to do is you're going to do your homework. You're not going to fly through it. When you're done, I want you guys to check yourselves. Okay? You're going to check your homework, and I want you guys to put a star next to the ones that you guys are super confident in, that you think you have the answer correct. Okay? If you look at that and say, I know I have this problem right, I'm not second guessing it, put a star next to it. If you look at it and you go, I don't really know that I have that right, or I think I could use some more help with that, circle it, okay? Ms. Shook has them circled in the homework. Circle it again. Circle it with your pencils. You're still going to work it out. You're not going to leave it blank, but that tells me I don't know all the way. I'm not confident that I know this answer, okay, that I know that this is right. So, I'm going to pass out your homework. You guys are going to be given about 10 minutes to work on it, okay? And then you're going to turn them into the basket like you normally would, all right? You guys can go and move back to your normal desk. And I'll come back and get your bus.